Now next we are going to discuss the balancing of the redox reaction through the ion electron method. Now students, the ion electron method, it's also like the oxidation number method. We have to first calculate out the oxidation number, right? And then we have to identify that which of the species is undergoing the oxidation and reduction. On the basis of it, student, we will just divide the equation into two parts, oxidation reaction and another is the reduction reaction. And then we are going to separately balance these two reactions. And at the end, by balancing the oxidation and reduction reaction separately, at the end we are going to combine these two reactions, keeping in mind that the number of the electrons gets equal on the both sides. Now these steps will be clear to you when we just do it by following the example, right? So let's start. First of all, we have written this is the equation MnO4 plus SO3 negative gives Mn2 positive plus SO4 2 negative, right? So first step is to write down the skeletal equation. So it is MnO4 negative plus SO3 negative gives Mn2 positive plus SO4 2 negative. So first you are going to write down the oxidation state. So here student, it will be plus 7 of manganese, oxygen it is minus 2, sulfur student it will come plus 5, manganese it is plus 2 here, and here it will come plus 6, right? Now from here it is easily understood here that here the oxidation number is getting decreased, oxidation number is decreasing, so here it is reduction taking place, and here it is plus 5 to plus 6. So here oxidation number has increased, therefore it is oxidation which is taking place, right? So first of all, this step should be clear that first will be the oxidation taking place of SO3 negative, right? And that of the manganese, it is plus 7 to plus 2. So here the reduction is taking place, right? So second step, we are going to split up the reaction. So let's first write for the oxidation here. So oxidation reaction, it is of SO3 negative giving up SO4 to negative, right? So here at sulfur is how much? It is plus 5, it is plus 6. So here it has accepted or it has lost its electron. So we are writing here because oxidation is always loss of electron, right? So this is the first step here. Then the second step, right? We are going to student balance the charges, overall charge on the species. So it is minus 1 here, it is minus 2 and minus 1, minus 2 and minus 1, that is minus 3 here, it is minus 2 here. So how can we balance it? We have got here the tool is, it is acidic medium, so we are going to add here H positive, right? So it is SO3 negative, it is SO4 2 negative plus 1 electron is here. We are going to add here H plus, right? So if we add here H plus student, so it is getting how much? How much H plus we have to add here? It is 1. It is here minus 1. Here it is how much? Minus 3. So to get it balanced, we have to add 2H plus in this way. So we have added here 2H positive. Now since we are adding here H positive, so we have to add, we have introduced here hydrogen, so we have to add here water molecule. So this is the water molecule which we have added. Now you can see here that oxygen 3 plus 1 4, it is 4 here, hydrogen 2 here 2. Check the charges, it is minus 1 and 0, minus 1 here, it is minus 2 and minus 1, minus 3 plus 2, it is getting how much? 1. So this is the balanced redox reaction, right? I am numbering it as A equation. Now come the third step, that is of the reduction. So on reduction student, we are going to write here this equation which is MnO4 negative gives Mn2 positive. So here you can say it is plus 7 to plus 2. So here the electron has been accepted, reduction has taken place. So how much? Plus 7 to plus 3, so it is 5 electrons which are being added, right? Plus 7, so it is getting plus 6, plus 5, plus 4, plus 3 and plus 2, 5 electrons. Now second step, we will just see the charge on the species. It is minus 1 here, this is minus 1 into 5, so it's minus 6 here students. So it is minus 6, and here it is how much? Plus 2. So how can we balance it? We have to add positive, a unit positive charge. So we are going to add on this side. So how much S positive we will add here? So it become plus 2. Yes, we have to add here plus 8. So it will become here MnO4 negative. If we add here 8, it will become plus 2. So it's minus MnO4 negative plus 5 electrons plus 8H positive gives Mn2 positive, right? So 8H positive we have added. So we have added here water, hydrogen. So on the other side we will balance it by adding the water molecule. So it is 4H2O. Now just see, it is 8H here overall. Here it is 8 oxygen here. So it is 4 oxygen. Here also 4. And the net charge you will say it is minus 1 and minus 5. It is getting minus 6 plus 8, it is plus 2 here, and there is also plus 2. So this equation is the balanced redox reaction, or reduction reaction, sorry. Now we are going to add these two equations. So adding equation A and equation B, right? So we are writing first oxidation, so it is SO3 negative plus H2O plus gives SO4 2 negative plus electron 1 electron plus 2H positive. And this next equation is MnO4 negative plus 5 electrons plus 8H positive giving Mn2 positive plus 4H2O. So before adding, students, you know that these two equations should get electrons cancelled out, right? So here we have 5 electrons, this is single, so we are getting it multiplied. This complete equation will be multiplied by 5. Now we are going to add it up. It's 5SO3 negative plus MnO4 negative. Here we have 5H2O, it's H2O, 5H2O, here it is 4H2O. So it will cancel out, here we will get H2O. This side we have 8H positive, but in this equation we are getting 2, 5, 10. So 8H positive will cancel out with this 10H positive. On the right hand side you will have SO4 2 negative, which is 5 SO4 2 negative plus 5 electrons getting cancelled up. 5 to the 10, we will get 2H positive plus Mn2 positive. Now this equation, student, it is the balanced equation, right? So it is this. So 5SO3 negative plus MnO4 negative. Mn is also balanced. 5s oxygen, it is 15 plus 4 19 plus 1 20. It is 5 4s are 20. Hydrogen we have 2, here also it is 2, right? And the charges, if you see, it's minus 5 minus 1, it is minus 6 here. Here it is 2 5 10 minus 10 plus 2. It will become how much? Minus 8, and minus 8 plus 2, which is again 6. So the net equation, student, is going to get balanced. Hope so the whole board is clear now, nothing is missing. Students, now next we are going to discuss the ion electron method, right? And we will balance it through the ion electron method and in the basic medium. So students, here the steps will be same, but here we have to keep in mind that we are going to balance the charges by using the OH negative in the basic medium. So first step, here the oxidation 0, it will be 0 here, sorry, here it is plus 2, right? And that of nitrogen, here it is going to be plus 5, here it is going to be minus 3. This plus 4 equals to, and this is actually nitrogen, you have to take x, it is plus 1 into 1 into 4 equal to plus 1. So it is equal to plus 1 minus 4, so it will come minus 3. So oxidation number of nitrogen, student, it is minus 3. Now first we have just calculated out the oxidation number. Second is to find out where the oxidation and reduction is taking place. So it is very clear here that where the oxidation number is increasing, we will say it to be a oxidation. So here it is zinc to Zn2 positive. Here the oxidation is taking place, and here nitrogen to ammonium ion plus 5, fallen down oxidation number. So here it is reduction. Now the third step, we will just split this reaction into oxidation and reduction reaction. So we let's say for Zn gives Zn2 positive. So it is possible with 2 electrons here. Zn gives Zn2 positive, 2 electrons lost, 0 plus 2 students here. Its oxidation number is 0. It is plus 2. Just check how we can get this 0 cancelled out. 2 electron here, right? Now the charges are balanced on both sides. Since there is charge are getting balanced, so here we are not going to add neither OH negative on either side, nor the water molecule. Now comes the reduction. As I said earlier that in the ion electron method in basic medium, to balance the charges, we are going to use the OH negative. So since it is balanced, getting balanced, so we don't require to add here the O negative. OH negative. So it is NO3 negative gives NH4 positive. Here it is reduction. You can see here that the nitrogen oxidation number was how much? It was plus 5. And here it has reduced to minus 3. So plus 5 fallen down, plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2 and minus 3. So it is getting 8 electrons. So we have to add, student, here 8 electrons. I think this is clear. Plus 5 jump down to minus 3, acceptance of the electrons. So plus 4, plus 3, plus 2, plus 1, then 0, then it will be minus 1, minus 2 and minus 3. So 5 plus 3, 8. So it has to accept the 8 electrons. Right? Now, students, just now we are going to balance the overall charge on the species. This was the first step. Now the second step. So to balance the overall charge, you can see here it is minus. It is 8 electrons. That means minus and minus 8. How much it is getting? Minus 9. Here it is how much? NH4 positive. It is plus 1 here. So how we can get it balanced here? We have to add OH negative. Here it is plus 1. So we can add minus 1 numbers here. So it is possible by adding here OH negative, right? How many OH negative? Here we can add so that the digit come to be a positive number. We have to add so here 10 OH negative, right? So it is, if it is, students, here 10 OH negative, okay, sorry, so you will add here 10 OH negative. So when you will add 10 OH negative, so it is plus 1 and it is getting minus 10, so you are getting minus 9. So that means you will add OH negative on which side? On the right hand side. So I am adding here 10 OH negative. So when we are adding 10 OH negative on this side, students, so we are adding hydrogen also. So we have to get it balanced. So I am adding here 5H2O gives NH4 positive plus 10 OH negative. Now just see overall hydrogen is balanced here. Is it so that the hydrogen is getting balanced? Here it is NO3 negative, N1, nitrogen 1, hydrogen is 3, 5 here, 5, 3, 8. But you can see that the oxygen and hydrogen, they are not getting balanced here. So that means here the slight correction is required here, student. Right? And what is going to be that how much water we should add here then? Since you can see it is getting 10, here it is 4. We need to add 14. So that is possible by adding 7. Now just check it again. It is 3 plus 7, 10, 10 OH negative. Hydrogen is 14, here it is 10, it is 4. So this equation is balanced. So here this equation was balanced, here this equation is balanced. Now add these two equations, adding equation A and equation B. So we have Zn gives Zn2 positive plus 2 electrons. Next is NO3 negative plus 8 electrons plus 7H2O gives NH4 positive, and it is how much? 10 OH negative. So before we balance, you can see it is 8, it is 2. So get this equation multiplied by 4. So we will get here 4Zn plus NO3 negative. Here it is getting how much? 7H2O. Here it is 4Zn2 positive plus NH4 positive, right? And it is 10 OH negative, right? Hope so this is clear that we are getting here 4Zn, right? 4Zn here plus NO3 negative plus 7H2O plus 4Zn gives 4Zn2 positive, NH4 positive and 10 OH negative. So at the end you will write it to be a balanced redox reaction, right? So whenever we are adding balancing the equation through ion electron method, we have to keep in mind that we have to balance the overall the charges on the left hand side gets equal to the right hand side, and accordingly wherever the side will be deficient in the charges, right? So we are going to balance it by adding hydroxyl ion, right? OH negative if it's the basic medium, and if it is the acidic medium, students, we will add H positive, right? Hope so this thing is clear to you all.